Hello and welcome to Venslov Academy. In this lecture we'll be looking into ROS, the Robot Operation System, and look at what this provides to the way that we develop robots. So basically ROS is a flexible framework for writing robot software, and it is open source, or at least most of it is open source, and was developed as a project initially at the Stanford Artificial Intelligence Laboratory. But ROS is basically becoming the standard within writing software for reusable robots. Because before ROS, when building a robot, it took a long time and was quite cumbersome because we essentially had to rebuild all the parts to each component from scratch. But with ROS, we can benefit from libraries and packages, which is also known within programming, where we can benefit from different packages and libraries in our code. So ROS is a framework, and it is not an operation system like, for example, Windows 10 or the Linux OS, but it works similar to our OS because it provides a way for us to communicate with the hardware. And within ROS, we have something called a ROS Master, and that allows us to communicate with different parts of our robot using what is called messages. But we will take a closer look at that later on in this lecture, where we'll look at a generic robot. But first of all, we will look a bit further into the history of ROS and who is maintaining it now and why, and what the philosophy of ROS basically is. So, ROS history. As mentioned before, the development of ROS began as a project in Stanford's Artificial Intelligence Laboratory. And in 2007, it got support from Willow Garage, which were a Silicon Valley startup. And since 2013, the open source Robotic Foundation has maintained and developed ROS, and it is also where you can find more information about the ROS operation system by visiting their website. And as mentioned before, one of the primary motivations for developing the ROS at the beginning were that when developing robots, people were essentially reinventing the wheel each time because they had no standard for implementing basic functionalities like communication between components. So ROS has really been focused around making robot software development a lot easier than initially. And the philosophy for ROS has therefore been that it should be distributed, meaning that a program can be run on multiple computers and communicate over a network, so it's not like developed specifically for one device and contained within that. And it is also multi-language supported, meaning that you can essentially write modules to ROS in a lot of different programming language, for example, the C++, Python, MATLAB, or Java. Basically, whatever language there has a client library support for it can be used. And ROS has also been built around the idea of being lightweight, meaning that libraries should basically be divided and wrapped around a thin ROS layer within the entire framework. And of course that it should be open source, such that both academics and the industry can use it freely and not have it locked away, meaning that people should license and pay upfront for using it. So most of the libraries and packages for ROS and the ROS fundamentals are open source license. So now that we have looked a bit to what ROS is and the history of ROS, let's take a look at a generic robot in order to understand what ROS is really doing and how we can benefit from it. So a generic robot most likely consists of three different elements. There is the sensing, meaning that the robot is sensing what is happening around it. That could be, for example, using camera or GPS. or some kind of text input. Then it has decision making, meaning that it take what it has gotten in the sensing phase and process that data in order to make a given decision, and based on the processing it will act upon the final decision. So for example, if we are sensing that we are located 1 meter in the wrong direction, we will make a decision to move 1 meter in the right direction, and in the acting phase we will then activate the motor of, for example, our wheels on the robot to move in that direction. So in short terms, that is what a generic robot looks, and that doesn't matter whether it is a flying drone, a underwater drone, or a surface drone. Most robots consist of this 3-element structure. So I mentioned the ROS Master at the beginning of this lecture, and the ROS Master is really what is the key for the ROS operation system. And the ROS Master is keeping a register of all the nodes within the robot and the system. So basically, if we take the 3 blocks, sensing, decision making and acting, each node within these could, for example, be a node could be the camera, the GPS, the data processing and the motor control. So our ROS Master here is like the manager of all these and has the control of what nodes is connected. And then each node is a given component within the robot. And by using the ROS Master, it will tell the other nodes what kind of nodes there are in the environment, and then the nodes can communicate using what is called node topics. And that is essentially how the generic robot is mapped down to the ROS operation system. And in the next lecture we are going to look further into ROS nodes, the communication and messages between them, and how they are subscribing and listening for information from each other, and how they can fetch information from parameters. So remember to like and subscribe, and then I will see you in the next lecture here on Winslow Academy.